Imagine two monsters, each millions of times the mass of our Sun, spiraling toward each other in the darkness of space. There's no sound, no light, just gravity pulling them closer and closer until they collide in an unimaginably violent event. A ripple spreads through the very fabric of space-time, and eventually, billions of years later, we feel it here on Earth. This isn't science fiction. This is real. And scientists have just detected one of the most epic black hole collisions in the history of the universe. So what happened? How did we detect it? And what does this tell us about the universe we live in? Buckle up, because we're diving into a story that bends space, time, and everything you thought you knew about reality. Let's start with the basics. Black holes are what's left behind when massive stars die. Think of them as cosmic vacuum cleaners. Only these vacuum cleaners are invisible, super heavy, and literally rip apart anything that comes too close. Now, most black holes are just a few times more massive than our Sun. But there are some, called supermassive black holes, that are millions or even billions of times more massive. But what happens when two black holes collide? Well, the result is a titanic merger, a cataclysmic event that releases more energy in a few seconds than all the stars in the observable universe combined. And now, scientists have recorded a black hole collision so enormous, so mind-blowing, that it's changing how we understand the universe. This latest discovery comes from the Laser Interferometer Gravitational Wave Observatory, better known as LIGO, and its European partner, Virgo. These detectors don't see black holes in the traditional sense. Instead, they detect gravitational waves, ripples in spacetime first predicted by Albert Einstein over a century ago. Back in 2015, LIGO made history by detecting gravitational waves for the first time. Since then, scientists have picked up dozens more. But this one? This was different. Here's why. The collision involved two black holes, one about 85 times the mass of the Sun, and the other around 66 solar masses. When they merged, they formed a single black hole with a mass of 142 suns. Why is that number significant? Because this new black hole is the first confirmed member of a new class, intermediate mass black holes. Until now, we had evidence of small black holes and supermassive ones, but very few in between. This is like discovering a new species in the middle of a food chain scientists thought was broken. Now, here's where things get weird. According to current theories, a black hole of 85 solar masses shouldn't even exist. Why? Because stars that massive, between roughly 65 and 120 solar masses, go through something called parinstability supernovae. In simple terms, they explode in such a way that they leave nothing behind. No black hole. Just cosmic dust. So how do we explain a black hole that clearly does exist, but shouldn't? One possibility is that this 85 solar mass black hole was itself formed from a previous black hole merger. In other words, this is a black hole made of black holes. Let that sink in for a moment. We're talking about a second-generation black hole formed from the cosmic leftovers of a previous collision. It's like discovering not just one T-Rex, but an entire ecosystem of dinosaurs living in a place we thought was extinct. This discovery isn't just a curiosity, it's a paradigm shift. For years, scientists debated whether intermediate mass black holes even existed. Now we have proof. And that opens up a whole new field of study. Where do these black holes live? How common are they? And could they be the missing link between stellar black holes and the supermassive monsters we see at the centers of galaxies? As Alan Weinstein, a physicist at Caltech and one of the LIGO researchers, put it, "This is the first time we've confidently detected a black hole in this mass range. It's a big deal." It also challenges our understanding of how stars die and how black holes form. It might even force us to rethink the entire life cycle of galaxies. And remember, this collision happened 7 billion years ago, before our own sun was born. The gravitational waves only just reached us. It's like getting a message in a bottle, sent before Earth even existed. So how do we even feel these cosmic ripples? LIGO and Virgo work by firing lasers down long tunnels and measuring the tiniest changes in distance, changes smaller than a proton, caused by passing gravitational waves. It's like trying to detect a change in distance, the width of a human hair, between Earth and Alpha Centauri. It's that precise. And when those ripples arrive, they carry a signature, a kind of cosmic fingerprint of the event that caused them. In this case, the signal lasted just a fraction of a second, but told scientists everything they needed to know. Two enormous black holes had collided in deep space. This discovery reminds us of something truly humbling. The universe is still full of mysteries we've barely begun to unravel. We used to think black holes were rare. Now we know they're crashing into each other across the cosmos all the time. And each collision is a window into forces beyond anything we can recreate on Earth. Every gravitational wave we detect is a whisper from the distant past, a ripple from an event so powerful it literally shook the universe. And yet, here we are, tiny beings on a pale blue dot, building machines sensitive enough to hear those whispers. If that doesn't make you feel all, I don't know what will. If you enjoyed this deep dive into cosmic collisions, make sure to hit like and subscribe. And let us know in the comments, what do you think is out there, waiting to be discovered next?